Greetings and welcome, friends. Mr. Waddy here in my Algebra Buddies. We are talking about properties of exponents. We learned about 5 of them yesterday. I've got them here. We learned that anything raised to the 0th power, which, by the way, depending on if you're English or not, I've seen zeroth kind of spelling, which I would still pronounce 0th, and I think I've also seen zeroth. I don't know. It's weird. But either way, anything raised to the 0th power is equal to 1, which isn't necessarily intuitive. It doesn't feel like that should be the case. The only time we don't know is when it's 0 raised to the 0. Doesn't matter. Negative exponents. If I have a negative exponent, one of the ways I could deal with it is move it down to the denominator, if it was in the numerator, and make its exponent positive. It does not produce a negative number, all right, necessarily, unless the original base was negative, it has a chance to. But what it does is it's the same as 1 over that value raised to... You guys can all stop talking, please. Thank you. All right, you just flip it. And if, let's say, it started in the denominator and I had something like a to the negative m, then I would flip that upstairs and I'd have a to the positive m left over. We also had the product of powers property, that if you're multiplying two things of the same base, you just add the exponents. The kind of inverse concept there is that if you're dividing two things of the same base, you subtract the exponents. And the order of this subtraction matters. It's going to be the numerator minus the denominator, right, Josh? And then lastly, we learned power of a power property, which is when I have an exponent raised to another exponent, which actually that can get written like, I've seen something like this before. You can actually get real crazy with a stack of exponents. Woo! But it turns out all you got to do is just multiply the exponents. So those were the properties we learned, and then we threw you into the mathematical wild. Here's question 7. All right. So in its current form, 5 is technically in a numerator over 1. It's just not shown. All right. All right, well, no worries. No worries. Let's keep going. So 5 to the negative 4th power, I'm going to move that downstairs, and I will get 5 to the positive 4th power. And when there's no one upstairs, 1 moves in, and that's one possible way of writing my answer. I actually like that. That's in what's called prime factorization. Okay, did it not accept that input? The other way you could have written that is actually do 5 to the 4th power on your calculator, and you get 1 over 625. So those are equivalent. All right. This next one, 11, is the same property, a little bit trickier. Ooh, man, this has multiple things. Let's take a look at the 6 first of all. 6 has a negative exponent. It's moving upstairs. Now, this minus sign is not connected to that exponent, even though it looks like they're pretty close. It would only have that exponent applied to it if there were parentheses around it. So this exponent is actually only applying to the 3, not the minus sign, oddly enough. And so I'm going to move this 3 downstairs. And that minus sign, I've got a couple options here. Either I could leave it out in front of the fraction, or you could leave it up in the numerator. I'm a fan of kind of out front if possible. So my new numerator, pause for laughs, audience. Internet friends, just so you're aware, the whole class is laughing. They're raffling right now. Oh my goodness. Guys, calm down, please. Oh, please. We're trying to get them. Oh, guys, come on. Yeah, good idea. One of the students said, let's add a laugh track in post. That's a great idea. So the 6 is now up top with a positive 2 as its exponent. The 3 is in the denominator with a positive 3 exponent. And that minus sign was unaffected by either. So careful now, friendos. Some of our fraction skills are going to come back. So I've got negative 6 squared is 36. 3 cubed is 27. That's not done. Both of these can be reduced. What's a number that goes into 36 and 27? 9. Good move. Good move. 9 goes into 36 4 times and into 27 3 times. So I reduce the fraction and I get negative 4/3. If you got it to like here, I would have been pretty happy with that. I'd give you almost all the points on, say, like tomorrow's quiz that I mentioned to you a moment ago when some of you were listening. And so that's that. I'm more interested today in your properties of exponents use than I am in your fraction use. Although check out my man Salman Khan on the Khan Academy if you need to practice some fractions. You know. All right. Let's take a look at let's up the ante here. All right. So you got this, Brandon. You're following me. I know you've got it. Don't distract your peers, please. Okay, here we go. So n to the 0th power is 1. That's right. That is right. So that's just going to be 1. I'm going to move the 2 downstairs, give it a positive exponent. I'm going to move the m downstairs, give it a positive exponent. And so I'm going to have 2 to the positive second, m to the positive third. N is equal to 1, but multiplying by 1 is just the thing, so I don't even have to write that. And then another 1 shows up upstairs. Let's simplify the 2 squared. That's 4. That's 4. Which, by the way, 2 squared is equal to 2 times 2. That's the only number, I believe, for which that's true. 1 to itself. Yeah, 1 to the first is 1, so is 1 times 1. So this is kind of an unusual outcome, right? Whereas, like, cubing or something like that would not give me the same results. So 2 squared is 4 m cubed. So 1 over 4m cubed is the result. Man, they're adding z's now? Yikes. All right. Don't be scared, friends. Rawadi's here. You've got the skills. We've got these properties of exponents to help us out. It ain't gonna be bad. Don't you fret. Okay, one at a time. Z to the 0 is just 1, right? Y to the negative 6th. It's unhappy living upstairs. Move it downstairs. X to the negative 7th is unhappy downstairs. Let's move it upstairs. And 8 to the negative 1st is unhappy downstairs. Let's move them upstairs. All right, so I've got all sorts of football play arrows, Madden 98 sort of diagrams going right here. Represent Madden 98. Also, actually, to be honest, hey, I'm going to be real. Game Day 98. I said it. Comment below if you need to. So 8 times 2 squared. Actually, friendos, guys, let's actually focus on the learning here. It seems like you're not. So 2 squared, let's simplify that right now, is 4. X to the 7th. 8 to the negative 1st became 8 to the 1st, which is 8. What's the question? Anything to the 0th power is 1. Is itself. Yep. Nope. 2 squared is 4. All right. And y to the negative 6 moved downstairs is now y to the positive 6. Let's multiply 8 times 4. That's 32 x to the 7th all over y to the 6th. And it looks like z to the 0 couldn't pay rent. They moved out, and man, now they don't have a home. That's sad. That's sad. I had to evict Z. I'm sorry. Ugh. All right, here's I like these kind of questions a lot. Requires you to think about it. Let's look for an error, okay, and then fix it. So x to the 5th times x to the 3rd, is that x to the 8th? Yes, because 5 plus 3 is 8. When you multiply two things with the same base, you add them. All right, so that's correct. This is still x to the 4th. Dividing two things of the same base, I'm supposed to subtract the exponents. So this is the error right here. That's the error. And so the actual outcome would have been x to the 8 minus 4, which is 4. Yep, x to the 4th. Yep. Oh, sometimes that I haven't looked at 35 myself, but yeah, sometimes there might be multiple mistakes, but still the correct answer. Ooh. What's the question? Comment? All right. All right. Last couple problems for today's video. And this was the new property here, the last one. We didn't have a lot of time to talk about it. P to the 6th to the 4th. What? Using the power of a power property. I have the power. He-Man reference. No. You multiply the exponents. That's all you do. That's all you got to do. So that's going to be the same as p to the 6 times 4. You don't even have to write that step out. I'm just writing it out so you guys can see where it comes from. Here's p to the 24. Ooh, this is a good problem. Multiple routes. Okay, yeah, let's work within this one fraction first. Dividing two things of the same base, I would subtract the exponents. So I'll get x to the 5 minus 4. And you could have done the 5 minus 4 in your head, I realize. Multiplied by the x there. I'm just writing it out so our viewers at home can see where our answers come from. 5 minus 4, in case you didn't realize, is 1. Sometimes. Although I wouldn't be surprised if this video gets some views from India or the Philippines. Yeah. So guys, actually, wait a minute. Is this fair? Did I change something here when I went from... I made it visible. Yeah, I went all Eye of Sauron on that hobbit wearing a ring. I see you, Frodo Baggins. So yeah, when there's no exponent written? Man, my son's name is Everett, right? Could I say Retton? You're just Retton. All right, I'll workshop this idea a little bit later. But anyways, x to the nothing written is, there's an invisible 1 hiding there. Multiplying two things of the same base, what do I do? Add the exponents. X to the 1 plus 1 is x squared. All right, well, thanks for watching, mis amigos de internet. Adios.